So with the ambiguous case of law of sines is the possibility of running into two triangles. Now, when we're looking at two triangles, let's see, with the so close. When you work with the ambiguous case for the law of sines, bless you. Again, what I'm going to do is a quick rough sketch of what we have. A, B, C, 16, 32, 92. Okay. Now, we know that the given angle is acute, so I have to check all the values. So my given angle is acute, so I'm going to check and see, is the side opposite it times the sine of 16. What I'm doing here, not side, is the side next to it times the sine of A, is it greater than the other side? I'm checking to see if this stuff works. Let's do it real fast. It is not greater than 32, so I know that this one's okay. I go to the next one. This one's all right. So is 92 sine of 16, we got that to be 25 and change. That is smaller than the side opposite, and it is still smaller than the side opposite B. So that means right now we're going to have the possibility, or we will have, excuse me, two triangles in this scenario. The reason why you can have two triangles within the law of sines is because when we use what we call the unit circle, you get ordered pairs. Everybody agree you have x's and y's are your ordered pairs? Well, in the unit circle, your ordered pairs are cosine and sine. All right? Now, think about your ordered pairs. In the first quadrant, your ordered pairs are both what? They're both positive. Over here, it's so if you use the idea of that ordered pairs throughout the unit circle, go cosine, sine. Sine is positive in the first and the second quadrant, which means that I can wind up with two different angles that has the same value for the sine. Okay? So what happens then is as you walk through this problem, we're going to solve for angle B like we would normally. And I'm sure most of you guys did that as your first step. Sine of 16 is the 32, as the sine of B is the 92. Do some quick cross multiplying out. Inverse the sine to get the angle B. I did this earlier. Yeah, the 52 and change, that's right. 5241. So what happens here is that you get an angle of 52.41. That winds up getting you the sine of that angle equaled out to be that of your decimal. Another angle on the unit circle that has the exact same sine value would occur in the second quadrant. I'm going to use a new vocabulary term here that we didn't talk about yet. This is weird. The reference angle, to figure out the other angle that has the possibility of having that same value for sine, is nothing more than 180 minus this value. So what happens then is that your angle B has two possible scenarios. It could wind up being at 5241, or it could be at 127.59 for B. If you take the sine of either of those two angles, it's going to equal the same number. It's going to equal the same number. So now what you have to do then to figure out the other two possible sides for A is you use law of sines with this angle to subtract out to find angle A. You use law of sines and subtract out this angle to find angle A the other way. So that means you're going to have two possible angles for angle A. All right? Again, this scenario leaves us, this one was 16, B is 52.41, A is, angle A can be something else, and then in this triangle, 127, 59, 16, and A is a different angle. And that's going to give you two different values for the side A, okay? Law of sines does occur in some instances where you can get two possible values. Yes, sir?
So basically, all we do is find the angle for one of the triangles and then subtract that from the one.
Correct. And that'll give you your two possible scenarios for the missing, that B value, that second angle that you had found. This only happens when you have the scenario of the two triangles, the ambiguous case, the weird case, if you will, okay? Once you do that, then it's just a matter of subtracting from 180 for both of these two to find out what A is, and then you just use law of sines one more time to figure out the possible side lengths for A. You're gonna get two sets. Yeah?
So then does it matter what angle you start with, what angle you solve for?
What'll happen here, if you look, what's the only angle that I can solve for to start with the given information? The only angle I can start to solve for is B because I'm given the value opposite it. Does that make sense? So if I was given the value of A, I'd find A. Working that way, I start with that one. Okay? And like I said, the only weird part about this is that as you walk through the problem, if you find out that you're going to get two possible triangles, once you use the law of sines to figure out what the possible angle is, get its reference angle from the second quadrant and subtract that from 180, and then use those two angles to solve out the rest of the triangle. So you wind up basically splitting your problem into two problems and continue on. That's really all there is to it. What happens with these reference angles, and like I said, this is something we're going to talk about more in depth as we get to the second portion of this chapter. Throughout the what we're going to call the unit circle, there are matching angles all the way around. Yes, sir?
With the two side lengths, so it stays in.
They will not be the same. The side lengths themselves are going to be different because if you think about it, if this is a 52 and a 16, that's going to give me a different angle here.
Then how do you find the side lengths?
What I'm going to do here, we were given across from the 16 to start with, correct?
Yes.
That was what, 32?
So that one will stay the same.
What do you mean?
The across from the 16.
Yeah, so will this one.
Okay, that makes sense.
Oh, I thought you were talking about the side A. Yeah, the opposite, the angle C that you're given, that stays the same.
Yeah.
What's happening here is basically, when you have an angle that measures 30 degrees here, depending upon how long or how short this is going to give you what that angle is, okay? It's going to fluctuate for those sides, starting with the one part here. It can be shorter, it can be longer, that angle doesn't change. That's what this is showing us, this ambiguous case occurs. Okay. All right. Question on how that sets up? Hopefully it's not that bad, right? Are there other questions then from the homework from a couple of days ago?
This one?
Then the bookwork.
Maybe 58. But I know how you're supposed to solve it. I'm just making sure I got the right answer for it. It's the one with the multiple triangles, and you have to use the law of sines in order to get all of them.
You just have to walk through it. You start with, because in 57 you figured out what the one side length was.
Yeah.
Then you reuse that side length to go around the other to the next triangle.
What was the answer to that? Was it
For 58?
21 Was it like 21.7?
Yeah, that's what they're giving in the book.
Got it.
Yeah, that was just, I just wanted to see if you guys, all you have to do is use it twice to walk yourself through. Very similar when you guys had 30, 60, 90 triangles. If this was a 60, and this was a 40, this is a 45, and you had to figure out what this was, and you were given this to start with, how do you walk yourself through it? It's basically kind of along the same lines, but just using law signs to walk out of it. Okay. But other than that, are we okay on the law of sines, John? All right. Please make sure your names are on that one and pass that one up. Mr. Murphy. Oh, from that Monday one? Can we get that one separately so that way I don't mix them all together? Yeah. For those of you guys that were gone on Tuesday from that field trip, do me a favor, let's make a separate pile of those, and I'll get that from you in a sec. Yes, sir.
Wait. Like, this is how we set it up. And then I'll just do 92 sine 16 divided by 32.
Yeah.
And then I would get.
Okay, so here's what this would be. This equals the sine of the next angle. So now you have to inverse it.
Oh, you have to inverse that.
There's your 52. You're just missing that secondary step. Yes, sir.
So for the two triangles, isn't that what it's going to be like?
Yeah, very similar. It's very, visually, that's kind of what it looks like. Yeah, exactly. I'm not going to ask you guys to draw it out, but if you're striking it into
But
two.
that's why
Yeah.
I see things.
So when you're
That's awesome. That's really cool that you can do that.
So when you're figuring out the angles, you inverse it, and then the sides you just leave it.
You press the button for the sides, you inverse it for the angles. Are you ready? Inverse for angle, they're both vowels. Press for side, they're both consonants. Consonants.
All right.
I have a degree in math.
Monday.
And I barely got that one.
Monday. That was Monday.
Well, what are you doing? Are you new? I thought you were saying Monday on this one.
Monday.
Wow. Sounds weird. I know you. Yes, sir. Yes, it is funny. It's not a bad. Why is today a bad day? The sun is out. There's a lake out in front of us. We've got a beautiful view. Let's go swimming.
We're on the lakefront.
What's that?
I fell, and then I ran out of contact, so I told him,
See, it's not so bad. You got a nice compliment. You got a nice spot. You're gonna be okay.
I mean, you might end up on the street.
You might end up on the street begging for change, but in the night, it's like happy.
Yeah.
You'll have to wear glasses. All right, so now, one of the things that you guys, a couple people were asking about from the worksheet that you guys were working on yesterday.
You could be the richest clown ever.
When you go through the worksheet here, a lot of times, I will tell you guys this right up front. You will never ever be asked to find the cosecant of 23 degrees. You will never be able to you will never ever be asked to do that. Okay? Because you're just pressing buttons. What'll happen here is, I should have said block this out, but I was running late, and I just made a copy and said, whatever. So here's what's going to happen. In your examples here, you'll be given this. Cosecant of theta is 12 over 5. Okay? And it'll ask you to solve the triangle. Now, what I want you guys to be able to do with that information is, well, what is cosecant? It's the reciprocal of sine, so it becomes
So it would be
hypotenuse over opposite. Does everybody agree on that?
Yeah.
Okay. So here's what happens. What you would do is, we're dealing with right triangle trig. Label it theta, and I know that my hypotenuse is 12 and my side opposite is 5. Could you use that given information to solve the rest of the triangle? Yes. Is everybody okay with that? That's the kind of question I would give you. I'd give you this secant. I would do something like that. I would not, you notice how I paired this out to make it look like it might be a triple? But it's not a triple.
Oh, what are we supposed to solve the last side and
Yeah, so we gotta find the angle. The angle here, you just take the inverse sine of 5 over 12, boom, there it is. Sounds like a song.
Inverse sine.
5, 6, 12.
I should remember it.
You get back and come to get this out here, but yeah, the inverse sine of 5 over 12 will spit out the angle. That's what I'm saying.
Well, that'd be 12 over 5.
The button itself is the inverse sign, so the button itself will spit that out for you.
Oh.
Now, the rest of the stuff on that worksheet should have been really, really straightforward about solving out the triangles. So I wouldn't even, to be honest with you, I wouldn't bother myself with the 7 through 14 stuff. Did you solve the triangles okay? Did you do the elevation depression okay? All right. Now,
First 7 through 14.
I could care less what your answers are. Don't worry about it. Yes, sir.
On the other side.
I'm getting there. On the other side, I think I had you guys go through what, the first 3 or 4? I don't remember how many I had you guys do. Now, the first 4 again, it's just using those scenarios. Are they how many triangles you're going to get? What did you guys have a question on as far as those were? Okay, well let's do this. Let's hold on to this. We'll use this as our homework then for tonight and start, because then I want to get into how we solve for the areas. Then I'll let you guys just get started. Okay? So, no, because here's what we've got. We left off last week, or on, excuse me, what day was that? Tuesday. We left off Tuesday about the law of sines, and then there was a way to use sines to solve for the area of a triangle. Basically, it's so easy. Whenever you have a triangle, all you're doing is taking, you're going to be given an angle, and the 2 sides that make up the angle. Yeah. And what you do is use the formula. The area of a triangle is always going to be 1/2 the 2 sides that make up the triangle times the sine of the included angle. These 3 formulas are exactly the same for nothing more than the following. 1/2 side, side, and then the sine of the angle. Those 2 sides, excuse me, though the angle has to be the included angle between those 2 sides for this to work. That's the only thing it's the only rule there is. The angle has to be the included angle. So it's the 2 sides that make up an angle, 1/2 the side times the sine of the included angle, and it spits out the area of the triangle every single time. All right, it's a very nice little shortcut to go through. Again, this is straight calculator work. All right, straight calculator work.
So it could be any twist or any 2 sides.
It's any 2 sides and their included angle. That's what you're using. Any 2 sides and their included angle.
Now does the included angle have to be like adjacent to the 2 sides?
It's the included angle. It's the angle between the 2 sides. Basically, this has to be side angle side.
It couldn't be like ACD.
No, you'd have to solve for the included angle. Yeah, this is always think. It has to be a side angle side scenario.
So divide.
Okay? Questions? Very, very simplistic. Yeah. For your areas, that's how that works. So if I'm looking at the example there for 12 and 13, if I look at number 12, we have a side angle side scenario. So it's 1/2 of 90 times 52 times the sine of 102. Press the buttons, bada bing, bada boom, and there's your area. And that's really all that we have left over. Okay? Now, you now know how to solve for 2 triangle scenarios within the law of sines, as well as how to do the areas. I think that leaves us without too much of a hassle then to finish out the 13.5 stuff now. Okay? So if you have not completely finished up the 13.5 side, we'll do that for homework. Right, we'll start that now. Okay? Mr. Randy.